ladies and gentlemen. Welcome to Munro and Associates. Many of you had asked for what does it look like inside of our facility? What do we do? How do we do it? Today we're going to give you a quick tour of our 47,000 square foot building. Let's get started and walk through and have a look at some of the projects that we've been working on. Well, here we are in the front lobby, but in these times of COVID-19 and whatnot, we have to do a lot of precautionary kinds of things. So we've got screens here for the for people who need to have their temperature taken. We have sanitation stations all over the company, and in back of me is the video that people are looking at when they come into the building to understand exactly what's going on. So let's move on inside the facility, and we can talk a little bit about what it is we do and how we do it. Munro and Associates does lots of work on lots of different kinds of products. We'll talk a little bit about them today. Sometimes when we're working with a company, we just go in and do training on how to use our systems. Sometimes what we do is we help them with a product that has poor quality or high cost or high labor, or they're losing market share. And occasionally what we do is we work on turnkey new product development, and that's what we're looking at here. This is the Club Car Precedent. The Precedent was a vehicle that was given to us by Club Car, and they asked if we could basically stay outside the box and give them a product back that would give them the next 20 or 30 years of total impunity. There would be no competition that could keep up with them, and that's what we did here with the Club Car vehicle. So what did we do? First off, the old vehicle used to be made out of aluminum or steel, and both. And this car has very little aluminum. Mostly what it is plastic. And we'll start off right here. This front case here is made out of sirloin. It has a sirloin skin. That means that it doesn't need painting. And there's very little painting on this product. If you watched our videos on the Model Y, you'll see that I'm not a really big fan of painting. And this works out quite well, because if a golf ball hits it, it just bounces off. If there is a mark, it'll be a little white mark, and you just rub it and it'll be gone. This lasts forever. The car itself has about 27 patents associated with it. One of them is a very simple one. They gave me a ride in this vehicle, or a vehicle, and it was raining in Augusta. The rain came off the roof, and it was covering me with water sitting in the passenger seat. I asked, "Where's the gutter?" They didn't know what I was talking about. This car has a gutter. The gutter goes all the way around the top side of it's called the monsoon roof, and then it comes down. These supports are actually eaves troughs that allow you to allow the water to come down and fold in behind the back wheels. This is a patent that initially about 15% of the take was simply because this roof was available for them. The things that we did for Club Car, we'll talk about those a little later, but one of the things we did was we talked to the people who actually own these things or run the golf course or play golf, or the people who ran the golf courses. And one of the things that we took special note of was the people who had to maintain the grounds. Golf courses cost a lot of money to keep up and running. The reason that we went to plastic was because nitrogen eats up aluminum and steel like there's no tomorrow. That's why plastic was a perfect opportunity for us. When we look at this product here, you'll notice that the wheels in the front are inboard and the wheels in the back are slightly outboard. This means that it tracks so that you don't have two wheels tracking on top of the same rut. Ruts are a big problem. Putting the monsoon roof in with the gutters dropping down in back of the rear wheels, that made it better. But another attribute was bringing those wheels in the front and the wheels in the back out. Those two items were extremely important to the people who were fooling around with trying to get the golf course up and running all the time. Another thing that we did, if we take a look on the interior here, you'll see that the instrument panel used to be just a flat piece of plastic. What we added were features that really didn't cost that much. Because we were going to a plastic injection molding for a lot of different reasons, we added features and functions that the old precedent or the old vehicle, the old club car vehicle, didn't have. The precedent is loaded with great opportunities for making the drivers and the passengers in this vehicle extremely comfortable. And speaking of comfort, this has a real suspension versus everybody else, which they have basically what we would call a buckboard suspension. The suspension is was designed by TRW under Munro's supervision. This suspension actually keeps people from bouncing out of the golf car, which was a big issue for the folks at Club Car. So if we look over here, we can see that underneath the seat are batteries. Batteries lasted about 6 hours, and then they were dead. So up north here, the battery pack would be a problem, because at noon, the sun comes up here at around 5 in the morning, and people are golfing at 5:30. So at noon, these batteries are dead. But what we created was a system whereby you'd undo a couple of bolts and disconnect the power, pick up the dead batteries or the used batteries, put them onto a charger, pick up charged batteries, put them back in, and in less than a half an hour, that car would be out there making money again. This was a gigantic advantage for Club Car over everybody else in the industry. Let's talk about a little bit about the things that actually happened and what we actually did with Munro. If we look at the chart here over at the wall, it says, what did Munro do? Well, we benchmarked the competition. We established focus groups, like I was mentioning, styling, engineering, supplier selection, plant layout, purchasing of automation, developing a logistics plan. By the way, we got 1,000 inventory turns per year, built up and qualified the first prototypes, and then we also supervised the first 500 car build. When we got all done, what did we get out? Well, in the first year, we wound up with 80% market share. The market share that we're showing at 66% fluctuates, but that was probably the worst year they've had. So they went from 32% market share to 66% market share. And you can see that the number of suppliers dropped, the assembly operations dropped, the fabrication operations dropped, the floor space dropped, but we could produce twice as many vehicles in a smaller space. Like I said, inventory turns were about 1,000 and the profits increased significantly. When we got all done, the responses from the people who bought the vehicles was astounding. One of the owners of a golf course where you get continuous salt spray said that out of 100 points, he'd give them 110, because after 2 years, there was absolutely no maintenance required. This comes only when you get someone at the top of the house, like in this case, Phil Traley's, where he said, we stepped aside and let Munro do it, make sure we were thinking outside the box. The Club Car is a good example of what Munro can do when you're looking at a total turnkey kind of operation. We've done a few vehicles. We've also done medical devices, parts of aircraft, lots of different things as a turnkey, and we can help out in that way. Okay, so let's talk about another type of job that Munro worked on. For 4 years, or nearly 4 years, we worked on the first revision on the Mini, going from what Izagonis came up with to what you see here. This project would be classified more as a leadership kind of role, and we call that the wall process, the product and process integrated wall process. This coupled with our lean design formulas and whatnot, gave Mini a chance to compete and survive and thrive in a marketplace where most people classified them as pretty much dead in the water. The Mini, as you can see, most people thought it wasn't making any money. It basically had a return on investment in about 2.5 years. This car made a lot of money, not only on what we did for the car, but also on the, if you want to call it, tchotchke that came afterward. All the little extras that you could buy if you were a Mini buyer. So this is a cult, something like Tesla, and all of the stuff that we did here can be summed up in about 3 or 4 letters. One here is from Chris Lee, who was the program manager, but we had the VPs, the president, even the folks from BMW, the higher up folks, sending us letters thanking us for our time. This is what we do normally for very large companies. This is a good example here of what can happen when bad things happen. This is the Chrysler Pentastar engine. It's a V6, a 3.6 liter V6. And this engine was supposed to be the savior of Chrysler, but unfortunately we had the bank meltdown. This engine was halfway done, and so Munro, when unfortunately Chrysler had to relieve a lot of their people, Munro kind of worked on some of the ideas and some of the formulation that gives you this engine right now. This engine won Engine of the Year in 2011, 12, 13, and 14. In 15 and 16, they changed the rules a little bit, but we had left lots of accommodation for the types of things that they were looking for, like direct inject and whatnot. So all of the things that were needed were already designed into this product. It was just a matter of changing the machining or adding more equipment. To give you an example of what an executive summary, not the report, not what all we did, this is the executive summary that goes line by line on every one of the things that we pointed out as being a good idea to change this engine. All of them are basically in here. So something like 1,000 pages or something. I don't remember how many pages, but a lot. So in here is everything that every executive needed to know. One of the examples of things that we brought to the party that was a new innovation, this engine cylinder head is actually also the exhaust manifold. So by taking the exhaust manifold out, we saved 160 million euros in facilities cost, and it's a 60 million euro save every year because that thing is not a separate part. It's built right into the cylinder head. Lots of good things happened here. But let's talk about other things that Munro has worked on. If we talk about things with wheels, then I guess we could look over here and you can see one of our F1 customers. If we look over here, you can see one of the electronics companies that we worked with, in this case LG, and we helped them save $18 million on that particular TV set a while ago. LG and Samsung are both of our customers, and both of them use our software and both of them use our training and whatnot to help their engineers understand what and how innovation should come about. So let's go out into the factory and you get a better chance to have a look at what's going on here at Munro & Associates. Let's walk this way. So let's talk about a little of the diversity that Munro's gotten involved with. If we look at that first illustration, that's basically a medical device that went from, in essence, 20% of the market share to almost 100, and that was something where we had to double the size of the plant in 18 months. If we look over here, this is a knitting machine for a German company. We helped them decrease their costs significant enough so that they could compete with their Chinese competitors and also gain market share in their European and North American customers. Let's move outside. So for our DoD friends, Munro was instrumental in helping out on the Javelin missile that you see here. Wind-corrected bomb. If we look over here at HARM, we worked on that product as well. We're moving over here with some of the other missiles that we've worked on. Then also, people call this the smart bomb, but really it's called the Paveway. We worked on this version and the European version, I should say, and also the normal version for the United States. We worked on MERM. We've been awarded many different certificates by different organizations. This was next generation warfighters weapon, and of course Excalibur is one of our best successes. So we talked about the engine that we worked on with Chrysler, the Pentastar. The question is, where do you come up with all these different ideas? And the way you do that is by benchmarking the competition. So Munro's been benchmarking competition in ICE world for a long, long time. We've analyzed hundreds of different engines, and it doesn't matter whether it's a 4 or a 2, an 8 or a 16. Munro has worked on lots and lots of different engines. These engines represent the best of the best. They have features and functions on them, these engine parts have features and functions on them that are unique or a characteristic that engine should have all the time. And that's why we get quite a bit of response from different companies trying to get into the engine business or trying to improve on their engines with cost, quality, and performance. These characteristics are things that Munro helps out our customers with a lot. So we talked a little bit about medical devices. What we're going to do now is we're going to show you a little bit about medical devices, white goods, and HVAC systems. So if we look here to your right, we're looking at some of the medical devices that we've worked on recently. These are redesigns. So the customer will send us a product, we'll look at it, extract where we think cost benefits are, and have ideas on how the product can be redesigned in order to increase profitability or decrease quality issues or decrease the labor that might be involved in getting the job done. If we look over here, we're looking at more medical devices, and if we look in the other direction, we're looking at HVAC ideas that we can use on other projects. Again, moving backward and forward, as we move in this direction, we're moving into white goods. So the medical devices that you see on the right-hand side and the heaters and cookers and whatnot that you see on the left-hand side, these things are everyday occurrences. What you're looking at is a very small amount of the number of products that we've actually done using our lean design methods and our design profit software. We've looked at, if you look here, you'll see on your right, you'll see microwave ovens, rice cookers, pressure cookers, a variety of different fans, hot water tanks, the Coca-Cola mixers, all kinds of things. And then as we get out here to the end, you'll see that we're looking at washers and dryers. Our biggest customer for white goods is Midea, and we help them go from number 3 to number 1 in 3 years. That's the type of thing that we try and do to help our customers to grow and to thrive in a market that's very tight from profitability standpoint. Let's walk over a little bit to have a look at our technical transfer area. Okay, so now what we're in is the tech transfer area, and you'll see there's a bunch of little kiosks that show different types of processes that are unique or special that we've decided to incorporate in our kiosk, in a kiosk, and also in our tech transfer area. This is a small sampling because most of the stuff we have obviously is on the computer. But sometimes it's a good idea to have something physical in your hands that'll allow people to grasp the idea in a better way. This is especially true when we do lean design training and lean design workshops, so that the people inside the workshops can see and touch and feel something that gives them confidence to implement into their own products later on when they get back to the shop. So this lean design area also has a light weighting area. That light weighting area helps for automotive, for aircraft, pretty much everybody who's looking for lighter weight for less cost. Let's walk over and have a look at the airplane section. Okay, so here we are showing us some samplings of aircraft types of projects. This is an aircraft door that came from a commercial aircraft. You can see lots of little pictures and whatnot, and you can also see black marks. Those black marks, because this is made out of carbon fiber, the black marks show where something used to be. These components that we've removed from the door panel, we did that so we could analyze them and figure out how much do they cost, How much do they weigh? What could be done to reduce that cost? What can we do to reduce the number of components and operations in order to get the job done? Like I say, this has got tens of thousands of parts and operations. Aircraft is, without a question of a doubt, the most complicated way of putting a product together. And so consequently, when we look at something like an aircraft door, it's very simple for us, in anything aircraft actually, to reduce the cost, improve the quality, and definitely increase the profit margin associated with aircraft in general. If we look at this product right here, this used to be an airplane. We took it apart. It used to be called a Republic CB. The CB was very, very interesting to us because the CB, the Republic Corporation, could produce this CB with 1/10 of the labor of a normal general aviation aircraft. This aircraft was very interesting. I wanted to know how they did it. And the way that they did it was by moving away from the normal stick build for an aircraft and going to an exoskeleton, similar to what Elon Musk is talking about when he brings up the fact that he wants to have the Cybertruck as a different type of a product. If we look in here, you can see that the inside looks relatively clean, and you can see that the skin is basically the structural member. There are a few ribs and longitudinals and longerons, but at the end of the day, most of this is taken up by the skin, which is relatively thick. The interesting part is that the actual weight, if we would have done this in a conventional way, the weight went down as well, doing something that everyone else said was impossible. To put that into perspective, let's have a look at the Eclipse. This is a small jet airplane that unfortunately failed because they could not get it out the door at a good price. And if you look at all the ribs, look at all the longerons, look at all of the fancy, incredibly fancy, different bits and pieces that are inside the Eclipse 500. That's why it failed. It failed because it was too complicated, too expensive, and couldn't hit its target market. If we turn around, we can have a look at some of the things that we did at Munro. Let's look up here at the little pink airplane. This is an aircraft that Munro was going to put into production. And if we look slightly to the right, you'll see that there's a picture there of the propulsion system. And I'm standing on a little pedestal, and I'm turning the engine on and off to show that this engine is different than a conventional aircraft engine. In fact, that was a Corvette engine. That's what we were using for this aircraft, and it worked phenomenally well. In fact, it worked so well that a Canadian company is buying Corvette engines and putting them into the CB. Our product and our process for the Paradigm, which was the little pink plane, was fairly extensive. Not only did we look at the powertrain, but we also created our own seat. We created something new. This is the laser weld bond operations. This is how one of our employees, Dr. Sue Munro, she got her PhD, basically showing how this is much, much faster. This would allow us to go from hundreds of airplanes per year to thousands to 10,000s of airplanes per year. And that's kind of what the that's kind of what the Paradigm was supposed to be all about. This is the controlling system. This aircraft could be flown conventionally, but you could also just talk to it and get it to where you wanted to go. This was tried out with 4 prototype aircraft. They flew senators and congressmen from Ronald Reagan Airport in Washington, D.C. to Danville, and everybody made it. There was no problems. Everything was perfect. And this plane, like I said, you just tell it where you want to go, and it'll take you there without getting you into any trouble with other aircraft or flying into storms or big trees or mountains or anything else. This was done in conjunction with the Michigan SATS organization, with Microsoft, and several other different people that all came together to come up with this new idea. Unfortunately, we didn't get a chance to put it into marketplace because of the 2008 bank turndown. Let's go and have a look at automotive now. About 70% of everything that Munro does is automotive. We do lots of work in trying to reduce costs and improving quality and adding what we call bewitching quality features. In order to do that, in order to do the costing and everything else, we had to develop our own systems and our own algorithms, which turned out to be some of the best in the world. We've gotten lots of credit from the EPA, from NHTSA, from CARB, and if you look up here, you're looking at the BMW i3 study. We don't do too many studies like this one. This product, as you can see, shows a lot more detail than we would normally put out, and goes through about all of the 50 to 60,000 parts that are inside of a product. If we look over here, you can see what's left over from the you can see what's left over from the Model 3, the Tesla Model 3. Over here, we have the Chevy Bolt, and in back of it are all the components that came out of that car. And then over here, we have the BMW i3, which was very interesting because it was, for the most part, 100% carbon fiber. Next to that are training stations for people who need to know about batteries. Each one of these different batteries has a unique characteristic and can be used in many different ways and has different science and different chemistry. People need to know, occasionally they need to know about what it is that we do and how we do it. So when we have people like that, we bring them in here, and this is the primer to get them up to speed so that we can talk to them in depth about their particular product or their particular project. So let's move into the work area. The red line basically says that anything on this side of the line is customer confidential. Today we don't have any customer confidential stuff, so we're going to show you what's going on here at Munro & Associates in the work area. So let's talk off first about what it is we do or how we do it. This is called a crush can, and if we look up here, you can see that that's what it looks like in the illustration. It comes out of our software. The software itself, you can see over here to your right. These symbols all mean something. We're not going to go into that kind of detail and not show you the whole map because it goes up to the ceiling. But at the end of the day, this is how we go into the detail that we need in order to describe how much everything costs. Every weld, every punch operation, everything we need to know is inside of our software. And then what we do is we get the results. And so in this case, for this is a Chinese product, we were within 5% of the actual cost that they finally did find out. We created this basically by getting that component and our internal knowledge. Let's move over and have a look at some other stuff that we're working on. What you're looking at is a project that was completed just before the shutdown. This is a project for obviously ICE engines. These are diesel engines, and these engines are the Ford 6.7, the GM 6.6, and the Ram, or the Cummins, I should say, 6.7 liter engines. These engines were brought to us by a customer. They wanted them to be compared. They wanted cost, they wanted quality, number of parts, weight, on and on and on. This is kind of what we do for engine companies to try and figure out where they are and where they want to be and what that gap is. Those gap analyses are very important to people who really want to make a serious dent in the marketplace. Not everything that we do is glamorous or automotive. Sometimes what we do is analysis like this one, which helped our customer figure out about packaging and how that they could reduce their costs and improve their quality. That sort of stuff happens every once in a while as well. So Munro & Associates isn't just a one-trick pony. We don't just work on cars, we work on everything from Barbie to the space station. Let's move on to the automotive stuff that you're probably more interested in. Munro has a good reputation for body in white or sheet metal products in general. And what you see in back of me here is an initiative study that we did for roof crush. This was something that was still a little bit on the secret side, but Nishta wanted to know how well different people performed and how they performed what they needed to perform and what materials did they use and what structural elements did they put in, on and on and on. So this is just a small snapshot of one of the things that we can do for different car companies or government agencies. So if you watched one of our episodes, number 16, on Munro Live, you would have got a chance to see all of the different electric motors that we've got sitting here displayed, and you would have probably heard about our 10 electric motor study. Electric motors are very, very interesting to us. As far as I'm concerned, powertrain is the heart of the vehicle. Everything else, if you've got a little gap problem or you have a little problem with your window not going up and down, all those things can be fixed. But if you have a bad powertrain, nothing works. So Munro's operation is to look deeply into how powertrain works, what's the electronics that makes it work, what are the batteries or what are the other elements that we need to talk about in order to make a good 100% uniform kind of powertrain that can give our customers the type of powertrain that'll delight their customers. So most of you have seen what it looks like from the hoist side of Munro & Associates, but this is the side where all of the magic really happens. These are the components that have been analyzed, photographed, and placed into our software so we could do the accurate costing that we needed in order to make everybody happy. If you wanted to see the other side of the factory where the hoists are and whatnot, you can tune into Munro Live, and there's plenty of shots like that. But this shot, what you're looking at here, this is the actual work area where we make the magic happen. So that pretty much concludes our a little tour here at Munro & Associates. Should you have been interested by what you saw and how we do things, please contact us at sales@leandesign.com. Thank you very much for attending, and be safe out there. Thank you.